Hey, what's up YouTube? It's Brian with Radical Prep. We're doing solving equations here, multiple variables. If you did the single variable lesson, this is the next logical one after that, and we're just going to work our way up. So this is a skill, solving with multiple variables, and one of the things you're going to have to do in the SAT, it's a beginner skill, but you got to have it down, is factoring out. So let's take some practice here, or do some practice, and see what you got. And again, you can download all these videos. I got the link in the window below. So the first practice skill we're talking about is factoring, and with number 1 here we've got 2ax plus 4bx. So we're always looking for what's in common on both sides. So there's a 2 here, so I can factor out a 2, and they both have an a. Actually, no, they both have an x. Sorry. And then you put your brackets or your parentheses, and you ask yourself 2x times what gives me 2ax. Well, you're just picking out what's left over. So you need an a. And for here, you need 2b. And that's it. That's what you should have for that one. Let's do the next one. 3dy minus 2dc. Well, only thing you can pull out is a d. We'll pull the d out. And you got 3y over here. And you should have 2c over there. Simplest terms, nothing else you can do. All right, so let's do this one. 3y cubed minus 9y squared z. So again, you're pulling out the numbers, or pulling out the coefficient the biggest amount that you can. So the biggest amount we can pull out is a 3. And we also we can pull out y squared. Okay. Sorry, that's y squared. We'll put brackets there. So 3y squared times what gives me 3y cubed? Well, you just need an extra y. Put the sign there, minus. 3 times 3 gives you 9. And we just have a z left over. So that's it. Simplest terms. And finally here, we got another more complicated one. So we've got x squared and x cubed. So we can pull out an x squared, y cubed and a y squared. So we can pull out a y squared. Put our brackets in. Okay. And to get x squared y cubed, we just need a y. And to get x cubed y squared, we just need an x. That's it. So those are the ones. I just zipped through it because I want you to practice them and check back and see if you got the right answers. So let's move on. Let me just erase this. All right. And we will go to, sorry, let me put this on the mouse here. We will go do, hello. I don't know why this is not responding. There we go. Okay. So let's do some more practice here. So I got a remember point. Remember, if a problem asks you to find x in terms of y, you get x by itself. If the problem asks you to get I in terms of j, get I by itself. Or c in terms of d, get c by itself. All right. So we'll see that because this is usually a term on the SAT that sometimes can throw students off. So let's look at number 3 here. This one says, sorry, getting my pen lined up. There we go. 2x minus ax plus 3bx equals 4. In the expression above, what is x in terms of a and b? So remember I said if it's x in terms of, you want to get x by itself. So x equals. So let's do that. Let me rewrite it. 2x minus ax plus 3bx equals 4. So since there's an x in all of them, I'm going to factor it out. So that's going to be x times 2 minus a plus 3b. Okay. And the whole thing equals 4. And now I can just divide out that 2 minus a plus 3b. And I'll do it over here. You know I'm just writing the same stuff. So x equals 4 divided by 2 minus a plus 3b. So not your typical SAT answer, but the idea is you want to be able to get good at practicing how to factor things out. Let's see how that helps us with a more SAT-like question. So if CD is equivalent to the expression 2c plus 1 over b, what is C in terms of B and D? So if this says if CD is equivalent, that's a fancy schmancy way of saying equals. So CD is equivalent to 2C plus 1 all over B. What is C in terms of B and D? So the issue we have right now is that we've got C's on opposite sides of the equation. So how do we fix that? Well, one way we can do that is, let's do this. Let's put this over 1 and cross multiply. So we get 2C plus 1 equals BCD, right? We just multiply these. Now let's do this. Let's minus the 2C. Minus the 2C. So we get 1 equals, let me erase that. Sorry, I got sloppy there. If I can get my eraser working. There it is. There we go. It's fun to use the eraser sometimes. So now we got BCD minus 2C. And what I'll do is I'll factor out the C's. So now I got C, I put my brackets, BD minus 2. And that should make sense to you, right? If you distribute it back, you get that piece, and C times negative 2 is negative 2C. So now I'm going to divide by BD minus 2, divide by BD minus 2. That cancels out. And your final answer is C equals 1 over BD minus 2. Hopefully that's an answer, and it is choice C. There's another way to do this. You could pick numbers for all this stuff and go back and plug and chug and do that. That's totally fine if you want to do that. Let's move on. Okay, now we got this issue again. All right, here. Number 5. So here's another one where we got cross multiplication going on. In the expression above, what is the value of z? So obviously the goal is to get z by itself. So let's start off and cross multiply. So we've got 2 times all this. So it's 2 times xz minus y. And that's equal to 5y. So I'll distribute 2xz minus 2y equals 5y. I just distributed there. I'll add the 2y, add the 2y, cancels out, and we get 2xz equals, what is that, 7y? Okay, and it wants to know the value of z. So we'll just divide out the 2x, right? The 2x, we want to get rid of 2x, so we get z equals 7y divided by 2x. That is 7y divided by 2x, choice D. You're done. Let's move on. A man walks around his rectangular garden and finds the longest side took J steps while the shortest side took K steps. So let's make a rectangular garden. I actually drew that pretty good. The longest side took J steps, so there's J, and the shortest side took K steps. Which equations below correctly expresses J in terms of K and the perimeter P of the garden? So that's a little confusing. Which of the following equations below correctly expresses J? So we want to get J by itself. But before we do that, let's just make an equation for the perimeter of this, because it talked, that's not K, I'm sorry. It talked about finding the perimeter. So before I worry about the equation, let's just figure out, or before I worry about getting J by itself, let's come up with a perimeter equation. So I'm just filling in the rest of what I know. So it should be perimeter equals 2Ks, right, plus 2J. 2Js. Sorry. 2Js. So what's the question? I want to get J in terms of. Remember I told you before, J in terms of, get J by itself. So let's do that. Let's minus the 2K, minus the 2K, cross out. P minus 2K equals 2J. And if I want to get rid of the 2, I just divide it out. So finally I get J equals P minus 2K all over 2. Is that an answer? So no, it's not an answer, but it doesn't mean you're wrong. Let's just find it. That could also be, now if I divide out, I showed you in another video or on one of the PDFs, the V method. if you can make a v, you can divide that denominator into both pieces. So that's going to be p over 2. I'll write it here. Let me write it right here. P over 2, and that's negative 2 over 2, which is negative 1, or negative k. So p over 2 minus k is the same as this one. So where's that one? P over 2 minus k. Choice B. It's right there. So this one, and I got my highlighter. Yeah. This one is the same as that one. Both the same equations. Okay? All right. Let's keep going here. What else we got? We have, let me just scroll down here. Okay, so this is how to find a common denominator. I'm not going to go through this with you, but when you download the PDF, check it out. It's all the steps how to do it. We're going to practice that right now. All right, so with number 7 here, if you were going to practice that, if you got this expression, in the expression above, what are you going to multiply 2 by? So let's say you wanted to simplify this, right? So you'd have to multiply by the same denominator as this one. So you'd actually multiply by f minus 1 all over f minus 1. You just take that denominator, put it on the top and the bottom, because anything over itself is 1. So that's like a legal math move. So here you'd have f minus 1. Sorry. I feel like I'm making a lot of mistakes right now. That's f minus 1. Okay. Sorry, let me fix that. F minus 1 all over f minus, I did it again. F minus 1. All right. I don't know why I keep messing that up. So let's figure out what that actually is going to equal now. If you do that, f minus 1 all over f minus 1, let's multiply that out. So there's the left side, right? So that's going to be, this is really 2 over 1. So multiply the tops, multiply the bottoms. So that's going to be 2f minus 2, I'm just distributing that, all over f minus 1. F minus 1. We got the same denominator, right? So numerators, 6 plus 2f minus 2 all over f minus 1. And then we have 6 minus 2. So that's going to be 4 plus 2f all over f minus 1. 4 plus 2f all over f minus 1. Choice D. You're done. That easy. Let's keep going. All right, so we've got... So that was multiplying fractions right there. I have another tip for you. And when you multiply fractions, when it's multiplication, it's tops times tops, bottoms times bottoms. If you get something that looks like this, where it's an addition or subtraction over, multiplied by a fraction, you still put this piece over 1, right? Put that piece over 1 like I did there. And again, tops times tops, bottoms times bottoms. Okay. Keep going here. We're making good time. I'll clean that up. Number 9. What do I do when it's a plus 2a over b? Well, we're using the same strategy as before, right? What do I multiply the lone thing by? That's going to be b over b, because I want to use this denominator, right? So now we're going to have, it's going to be b over b, and a is really a over 1 plus 2a over b. So you should get ab plus 2a all over b. But what's the problem? Well, none of our answers look like that. So here's what you're going to do. You can pick numbers again to try and figure it out, but we're not going to do that. This a is in both of them, right? So just factor it out. A times b plus 2 all over b. Now they even pulled out a fraction here. So really what they did was they pulled out that piece. So you really have a over b times b plus 2. That is a over b times b plus 2. Choice B. Okay? So not really a bad question. Let's look at this one. All right, so we got number 10 going here. It says 4f plus 6g times g over 2f. So one of the things I might do with this problem is factor out this expression first right here. And I can take a 2 out of that. So that'll be 2 times f, or excuse me, 2 times 2f plus 3g. And then I still got this next to it, g over 2f. And what's nice about that is the 2's cancel out. So that's gone. Okay, so now why don't I multiply g over f times everything and distribute? So that's going to be 2fg all over f plus 3g squared all over f. And you can start canceling things out now. F over f. So we have 2g plus 3g squared all over f. And the question is that an answer? 2g plus 3g squared over f. That's right here. Choice A. That's it. You're done. Choice A. Let's move on. So now we'll do number 11. And I put a strategy here, the V method, just to help you guys out. If you ever see an expression like this, a minus b over a number, you can make a V and set it up into two different fractions. So I'll show you an example over here how it works, but here's the method. So on paper here, I could draw V. So this was 3bc over 3. So that's literally 3bc over 3 minus 2c over 3. If you wanted to set that up and write it differently. So the 3's would cancel out, and eventually you'd have bc minus 2c over 3, or you could write it 2/3 c. It's all the same stuff. Just trying to get you to think flexibly and write express numbers differently, because that's what they're going to have you do in the SAT. So number 12 here, which is very similar to one we did a second ago. Let's see if you guys can do it on your own now. All right, so number 12, give it a try. And you can pause the video. I'll go through it right now. We have 2f plus 8g. So what am I going to pull out? I'll pull out a 2. So that'll be f plus 4g, and still multiply by 3 over 2g. So the 2's will cancel out, right? Because that's 2 on the top, 2 on the bottom. And now let's multiply what's left over. So that's 3 over g, and distribute that into both. So that's 3f over g plus 12g over g. The g's will cancel out, and all you're left with is 3f over g plus 12. 3f over g plus 12. 3f over g. Oh, choice C. There it is. And we move on. So these are just getting you to practice, get comfortable with a fraction times an expression. So the next strategy we'll look at is getting rid of fractions in one fell swoop. What the heck does that mean? Well, I got a bunch of practice problems here, but the idea is sometimes you don't want to find common denominator. You want to get a number that you can multiply the entire equation by to get rid of all the denominators. So here's the example. 3x over 2 plus 4x over 5 equals 15. You don't want to do the whole common denominator thing. You could just say to yourself, I'm going to multiply the whole fraction by a number. In that case, the number is going to be 10. I just did 2 times 5. Why do I do that? Well, 10 over 2 is 5. And 5, so it's going to be 5. I'll write the first one out the whole way. 5 times 3x. Oop, 3, sorry. That's going to be 5 times 3x. I got a little messed up. 5 times 3x. What's 10 over 5? Is 2. So that's 2 times 4x. And remember, you got to multiply 10 times everything. So that's 10 times 15, which equals 150. So that'd be a nicer way to do the problem because you don't have to deal with fractions. All right, so now this one. 2x over 4 plus 1/3 equals 8. What can I multiply everything by so I can get rid of the denominators? Hopefully you said 12. So what happens when I do that? So remember, 12 is on the top, 4 is on the bottom. So 12 over 4 is 3. So that's going to be 3 times 2x. 12 over 3 is 4, plus 4, and 12 times 8 is 48. So again, I'm not asking you to solve the problem, I just want you to be able to set it up. All right, the third one here. What am I going to multiply by? Well, you notice that there's some x's here. So I'm going to need x in what I multiply by. So let's do this. Sorry, I'm just going to draw the arrows again. So 2 and 3. What's 2 times 3? 6. And we need x's. So now, 6x on the top, 2x on the bottom. The x's cancel out. 6 over 2 is 3. So that's going to be 3 times 3 for that expression. 6 over 3, and I'm looking at the middle one now. 6 over 3 is 2. The x's cancel out. So that's 2 times 4. And finally, 6x times 5 is 30x. All right, cool. Sorry, it looks like this last one got cut off. So that should be a y. That's a 5y. That's a 3y. And that's a 5y. Okay, so again, I'm just asking you to set up the problem. So since we've got 3y and 5, well, let's do this. Let's multiply by 15, because that's a number 3 and 5 both go into. And I'm actually going to use y squared. And the reason you want to use y squared is because you don't want anything left in the denominator. So watch what happens. What's 15? And again, I'm multiplying this times the first one. 15 over 3 is 5. Y squared over y, only one of the y's gets crossed out. And then that whole thing is going to be times 15x. Plus 15 over 5, so now I'm doing the second one. 15 over 5 is 3. Y squared over y squared cancels out, so we're good. So that's just going to be 3 times 7. And finally, 15y squared times the n there is going to be just 15y squared. And you're done. So here the practice was just figuring out what number you can multiply the entire thing by to get rid of all the denominators. All right, so you got all your answers there. You can always go back, check your work. Let's go down and do some actual practice. So let's practice here on 12 and 13. 12 says 1/3 y minus 1/4 z equals 5. What is the value of 4y minus 3z? So I'll rewrite this again just because sometimes it helps you think. 1/4 z equals 5. So we just did questions like this, right? So we've got a 3 in the denominator and a 4. What's a number I can multiply everything by to get rid of the denominators? Hopefully you said 12, right? So 12 times 1/3, that's 12 over 3 is 4. So that's going to be 4y. 12 over 4. So now I'm doing the second one. 12 over 4 is 3. And what's 12 times 5? Hopefully you said 60. So now 4y, and the SAT will, I'll just put the arrow for the last one. They wanted 4y minus 3z. Well, you got it. 4y minus 3z. So your final answer is 60. Okay. Finally, the last one. 2a minus 1/4 b equals a half. Which of the following is equal to 6? All right, so now this thing is equal to a half, but I want it to be equal to 6. So what can I multiply the whole thing by to get that equal to 6? I'll give you a second to think about it. But hopefully you said, and it turns out I didn't mean this to happen, but hopefully you said 12. I'm going to do the same thing. If I multiply everything by 12, what's 12 times a half? Well, that's 6. Now I got to do the rest. 12 times a fourth. So that's 12 over 3. That's going to be 3, and we have to put the b in there. 12 times 2a is 24a, right? I'm just multiplying that last one. So 24a minus 3b. 24a minus 3b. Boom, you're done. All right. So definitely review this one or this lesson about multiple variables. If you had trouble with this, email me. But this is something you're going to have as a beginner to do the more advanced ones. All right, so keep going to radicalprep.com. Good luck with your studies.